We're doing section 3.5 and we're doing example 5. And this has to do with the accuracy of an experiment is often judged by comparing the experienced value to a correct known value. So if you're doing an experiment in class and they already know what it should be and you get one number, you're going to compare it to what it should be to find out what the percent of error was. If you get the same thing, then you didn't have any error in your experiment. If it's small, then your error in your experiment was very small. If it's large, then I suggest you do the experiment again, figure out what you did wrong. So you're going to use that percent change formula with the experiment error formula. By doing this, you're going to take the difference, because this is the change, the difference of the experiment value, in other words, what you got for the experiment, what they tell you it should be, and you're going to take the absolute value. That's what these little symbols means, the absolute value. So this can end up being a negative number or a positive number, but when you take the absolute value, it turns positive, all over what the known value should be. So if we look at example 5, it says, in chemistry class, Jonah determines the density of copper to be. So he did his experiment, and he found that the density of the copper to be 8.83 grams per centimeters cubed. While the accepted value, so this was his experiment, this was his results, this is the experiment's results, all right? But an accepted value, all right, for copper, they tell you is 8.96 grams. So determine both Jonah's experimental error and his percent error. So the first thing we're going to do is we're going to find when it says experimental error, they're talking about the change, okay? So that error would be his experiment, all right, 8.83 minus 8.96, all right, and we subtract that, and we're going to get 0.13 grams centimeter cubed, okay? So this is basically, they're calling it the experiment error, but really what you're finding here is just that simple change, okay, of these values. So that's the change. Now, this is not a correct answer because this is smaller and this is larger, and I'm subtracting it. So technically, I got a negative number there, so it should be negative 0.13. And this is where people make a lot of common errors. All right, so this is a negative number here. So remember, when you're dealing with the positive and negatives, what are you going to get? Now to find the percent error, you're going to take this change, the absolute value of negative 0.13, divide it by the known value or the actual value it should be, which is 8.96. And we're going to also, you're going to multiply that by 100%, right? Because that's the formula, right? Well, when you multiply this by 100, what happens to this decimal? It moves over 2 places. And the absolute value of a negative number is negative, and the absolute value of a positive number is positive. So you're going to end up getting 13, positive 13, over 8.96. Go ahead and get an approximation out on your calculator, and you get 1.5, and then add your percent. So it was a 1.5% error. Is a 1 point, well actually, if you divide this out, you would get something like on your calculator 1.50, and just they rounded. That's what they did, they rounded. So if you need to know how I got that number, they rounded it. Okay, if it's 5 or greater, you round up. So that's how I got the 1.5%. I'd want to make sure you understood that. So that's not bad. A 1% error, that seems kind of low as far as that goes for example 5. Now let me give you a practice problem. Here's your practice problem. I'll leave my formula up there. You might put this formula on your quick reference guide or your notes somewhere. Oh, practice. If an experimental value of 126, so if they did an experiment and they got a value of 126 when they got done with the experiment, this is the results of the experiment. But the known value, and I'm just going to give them to you. You don't have to know what the experiment actually was. The known value is 129. Find the common error find the following. Okay, so I want you to find the experiment. So there's 3 things I want you to find here. I want you to find the experiment error. Remember, that's the change. I want you to find the percent error. That's using this formula. And then find the percent difference for the two. Oh no, that's all I want you to find. That's good. Let's just find those 2 things. Go ahead and pause. See if you can figure it out. Come back and tell me what you got. All right, so if you found the experiment error was a -3, found out the percent error was 0.2%, all right, then you did it correctly. But let's go ahead and work it in case you didn't. So the percent error, how did I find this? Well, I took 126 minus 129, and just so you know, that's the same thing as this. So when you subtract here, you're going to get a -3. That was that one. Now I find the percent error. I'm going to use this formula. So I'm going to take the absolute value of a -3 because that's the change. That's what we found here. Over the known value. The known value is 129. In other words, that should have been what the correct answer was. Right? Take that times 100%. Well, absolute value of -3 is 3. And 3 times 100 is 300. And when we work that out on the calculator, and we're talking about percents here because it's already in percent, and we're going to round, and in this case this is less than 5, so we don't need to add 1, we just go ahead and leave it at this. So this was a higher percent as far as percent error, as far as this practice goes. All right, so we'll pause and we'll work on example 6 in our next video.